So yesterday we sort of started in on domain and range, and we revisited kind of everything you learned from 8th grade math about domain and range. And ultimately what's really important to remember here today is that your domain is the values that are in your x coordinate, and your range are the values that are in. They are what we call discrete. That's a lot easier. And this is sort of along the lines of what we did yesterday. We'll revisit this. But then when we have a continuous or connected graph, what values are in the domain and range are a little bit more complicated. So again, this is discrete. These are individual dots that probably represent some sort of data. These are lines and curves, which represent so everything in between all those little points are all part of your domain or your range. So domain are your x's, range are your y's. This is discrete. I find the easiest way to do this is to list the ordered pairs first. So real quick, let's remember that when we list ordered pairs, we list the x first and the y second. So we read this point here, for example, is the point 1, 2, -3, 0. Then we have -2, 2. Then we have 0, 3. And 1, 0. And 1, 2. And then so once you list your ordered pairs, you can just go back to what we did yesterday and pull your x's and pull your y's. So this is sort of new notation, and we're going to talk more about this a little bit today. So the domain is all x such that x is equal to, and then we're going to pull our x values and just write them down. -3, -2, 1, and here we've got 2 1s. You don't list both 1s, you don't need to. I mean, not necessarily that it's wrong if you do, but you're not going to see it relisted. And then we're going to have the range. The range are our y values such that y is equal to 0, 2, 3. We've got a 0 again, a 2 again, and a -1. So here are these exact spots and nothing in between. Now we're going to talk about what happens when it also includes everything in between. Down here we just sort of have notation and get acquainted. So domain, this is our our x value. And when we read for our domain, we're going to read from left to right, like you would reading a book. And when we have our range, you're going to read from the bottom. And then we need to talk about our symbols. And we're going to use 2 different symbols today because I think it's important to be comfortable or at least familiar with both sets of notation. This will make much more sense when we get to the other side, but you're going to have a graph. You're going to have graphs. If you flip over in the back or look forward, you'll see. And these graphs are going to have several openings. Or you could have a closed circle. Closed circle means that you're going to use the less than or equal to sign. It means that, and that's just like we've always done with inequalities. The closed circle means that point is included as a solution. If you have an open circle, you're going to have no equal sign. You're just going to have less than. If you've got an arrow, and that means that the line goes on the less than sign. And then we talk about positive infinity if it's going in the positive direction, which would be either left or up, or negative infinity if it's going left or down. The other notation is brackets and parentheses. So if you have a closed circle, we talk about using a bracket. That tells us that whatever point it is included. Parentheses, less than. We also use parentheses when we're using infinity. So what I do is every time I'm going to start a sheet, I think it's important to kind of write your notation so you can kind of just reference up. So if we have an open, that's a closed. If we have a closed circle, we're going to be using either brackets or less than or equal to. And this is our open circle. We're going to be using parentheses or the less than sign. And you could add infinity or negative infinity. We're going to use brackets. I'm sorry, parentheses. Don't forget, domain goes left to right. Domain is our X, range is our Y, and we're going to go from okay, so let's look at this first one here. If this were discrete, your X value would be 1, 2, 3, negative 3 and positive 2. It's not that. It's everything in between as well, because the line goes on and on straight through. Each and every single one of these little points is included. It goes for the Y's. So what does that mean? It means we're using different notation. First thing I'm going to do, and I don't usually do this, but it will help for learning, I'm going to identify my points. This is the point negative 3, negative 1, and this is the point 2, 3. Now, we're going to read our ranges are Y. How far left do our X values start? Remember, we're reading from left to right. Well, they start here at this point here. What is this point? This is the X value of negative 3. Now we have a closed circle, which so we're going to look back up, and that tells us we're going to use less than or equal to. Then what are we doing? Well, we're doing our X values. And how go? So they start here, and they're negative 3, negative 2.9, negative 2.8, negative 1, 0, 1, and they go all the way up to this X value here, which is the X value of 2. What's our equality? Well, we've got another closed circle, so we're going to do less than or equal to 2. So this tells us that our X's, our domain, are everything from negative 3 all the way to and including positive 2. Then we're going to do our Y's. Start at the bottom. What is our lowest Y value? Our lowest Y value is the point negative 1. We've got our closed circle. So we're going to use less than or equal to. We're doing our ranges, so we're talking about our Y's. Up. I don't know which side you would want to do that on. But if we move up, where does our line stop on our Y's? It stops here at the point 3. What is our inequality sign? We've got a closed inequality. So we have less than or equal to 3. So if you want to look at it, and I wish I had a highlighter. For example, let's look at our Y's, our range. Our Y's start here and go up to here. That's kind of what we're doing. And they're not along the Y-axis, but they're anywhere in between. So this point, 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 that point, that point, that point, that point, that point. All those points on the y-axis are included on that line. Other notation. So the other notation is using the brackets and the parentheses. So again, we're going to look at the lower points, the upper points, and then whether we have closed circles or open circles. So here we've got a closed circle, so I'm going to use a bracket. And what is our domain? Well, it starts at -3 and it goes to 2. What's the equality sign there? We've got a closed. And this is basically just telling us that our x's go from and including -3 to and including +2. And our -1, we used, again, a closed circle, so we're going to use a bracket. And we go to 3, and we're going to use, we've got the equal sign again, so we're going to use a bracket. Circle and an open circle. So let's look at our domain, moving from left to right. Again, I'll go ahead and mark these points. This is -3, 4. This over here is to -3. Okay, so what are our x's? Starting all the way as left as we can go. We start here, which is the x value of -3. Circle, so we're going to have less than or equal to. What are we working on here? We're working on our x's. And how far right does our graph go? Well, it comes all the way down to here, which is the x. What is this x value? This is the x value of 2. But this time we have an open circle, so I'm going to only put less than 2. So this is telling us that our domain use less -3, including -3, all the way to, but not including +2. Ranges going from bottom up. Starting here, this is our lowest y value, which is the point -3. Oh, just because it happens to be the same. What's our inequality? We've got an open circle, so we have less than. What are we working on? We're working on our y's, our range. Up to what? Well, our graph goes up to here, which is the y value of 4. Closed circle, so less than or equal to 4. All right, and then let's do brackets and parentheses. -3 has a closed circle. That's my bracket. But our 2 has a open circle, which means we're going to have a parenthesis. And I know that looks a little funny, but it's how it's done. Here, we've got our lower value has the open circle. So we have a parenthesis, -3, to our upper value of 4, which this time we have a closed circle and a arrow. So this line goes on and on and on and on and on. Well, so where does this line start as far as our leftmost point? Well, there is no leftmost point. Now, that means we're going infinity, but because we're going down the x-axis in the negative direction, we're talking about negative infinity, we're going to use less than, talking about our domain, so x, and how far do we go? I didn't mark this point. This is the point 2, 3. So it goes up, our rightmost point is this point here, which is the y value of 2. Less than or equal to 2. Range, again, you're going your bottom of your graph infinity. So negative infinity less than y this time because we're doing range. And what's our uppermost point? It's this point here, which is the y value of 3. Oh, I'm sorry, closed circle, so less than or equal to 3. Or with infinity, we're going to use a parenthesis to 2 with a bracket because we have an equal sign, and negative infinity to 3 bracket because we have the equal sign. All right, this one is even more different. So we've got a hump in our graph. Makes it a little bit more complicated. Let's talk with first, obviously, about our x's. Let's negative 2, 2, negative 2, negative 2. And this is 4, 0. So let's look at our domain. Where do our x's go? So starting left, our x starts here. That's the y value of negative 2. X value. Closed circle. So less than or equal to x. Left to right, it goes to this point here, which is the y value, the x value of 4. Open circle this time. So I'm going to have less than 4. All right, so that wasn't so bad, but let's look at our y's. Our y's are definitely going to be different. Starting at the bottom of our graph, the y-axis of our y's. It's this point here. That's the point negative 2. All right, closed circle, less than or equal to. What coordinates are we looking at? We're looking at our y's, doing our range. How high does it go? Well, the end of the graph is here, but that's not the highest y value. That's a y value of 0. If you notice, I have points on this graph to look at the highest point on our graph. I don't know if that will show up any different. It doesn't, and I don't have a highlighter. What is this y value? This y value is the point 1, 2, 3. So this is y is equal to 3. So this is the point 1, 1, 2, 3. This is a point 1, 3. Highest y value is 3. Now when we do this, our 3 is included. So we're going to have less than or equal to 3. Or closed circle, negative 2 to open circle 4. And 2 to closed circle, included, I guess, 3. So bracket, parenthesis, bracket, bracket. Here we've got a vertical line, infinity in both directions. Domain. Well, this is 1, 2, 3. X is equal to negative 3. Well, what is this point? X is equal to negative 3, negative 3, negative 3, negative 3, negative 3. The only value of x is negative 3. So you could write that like we did on the front. X such that x is equal to negative 3. What about up does it go? It goes negative infinity to infinity. Now, there's this notation that we've been doing, which is fine, but all y values from negative infinity to positive infinity are included. Really, we usually say that that is all real numbers, and we write all and then a big R. The range is the set of all real numbers. And horizontal line at the point y is equal to -3. Well, our domain, how far left to how far right, is negative infinity to infinity this time. So I'm going to do it the exact same way. Spot. So, no, not that. Less than x is less than infinity. But again, we want to write this as all real numbers. I did this one wrong. This does not have equal signs there. Sorry about that. And then our range is y, such that y is only equal to -3. And that is domain and range from a graph. It takes some practice, but